Hello, I welcome you all in this presentation related with the subject failure analysis and prevention. In this presentation, I will be talking about the reliability, which is very much related with the analysis of the failures, which will help us also to see what is the possibility of the failure of a particular product over a long period of the service. So, this is done based on the history of the failures of same kind of the products. So, the topic is basically the reliability. So, to understand the reliability, first of all we need to see it is to be understood that how good a product is, so that it will perform the desired function for a certain period of time. How a product is reliable means it will deliver the job, it will deliver the goods, it will deliver the services which are expected from it. If a particular product is able to deliver the required function effectively for a specified period of time, we will say that product is reliable. So, but to define this specifically, like it is reliability is the probability, basically probability to perform, probability of course of a product or of a system or of an individual process. So, to perform the intended function for a specific period of time. So, it will be like 2 months or 2 years or 10 years or 2 hours, like that only, for a specified period of time under certain operating conditions. So, there are certain constants also. So, reliability will be comprising these 4 components. One is the probability to perform, and the second is the performing the desired function. So, if the system is performing but not giving that desired results or not able to deliver as expected, then we will say that system is not performing well and it has failed for a specified period of time. This is the another component. So, probability to performing the desired function and for a specific period of time, and then certain operating conditions, because if our operating conditions change, then this probability to perform may change. Like if some product is able to perform properly under the ambient conditions, but the same may not happen in case of the either low or high temperature conditions or in corrosive environment. So, the probability to perform the intended function will change with the change of the operating conditions or those specific conditions for which the probability has been means the reliability has been defined. So, this is how reliability is defined, and it primarily comprises certain things. What are those? There is a probability means one numerical value which will be indicating the probability to do the job for a certain period of time. So, there will be of course time period at the moment, at a particular moment for which the reliability is being checked or the seen. At the same time, we need to also mention the conditions under which it will be performing. So, the rate of failures may be different under the high or low temperature conditions as compared to those under the ambient conditions. So, we need to also specify the conditions under which this kind of probability of a product or a system will be to perform for a specified period of the time under a specific set of conditions. So, this is what has been presented in the slides, like ability to perform, ability of a product to perform as expected over a certain period of time, and it is defined as a probability of a product or piece of equipment or a system that will perform its intended function for a specified period of time under a specific operating condition. So, in this way the reliability comprises 4 components. One is the probability, it is like a numerical value that a product will perform satisfactorily for a particular period of time. Second is the function, the expected work or the job which will be done by a given product or the system, and then the life, how long the product will perform, and at which moment of the time we are trying to assess the reliability of the product with regard to the performance. So, how long the product is expected to last, the product life is specified as a function of use and the time or both. So, there can be any number of ways to specify the life. For example, the tool life in metal cutting can be specified in the number of ways, like continuous machining for 2 hours, or if it is not the actual machining, the total time of machining, which also includes the idle time. So, it may be 10 hours, or tool life can also be expressed say number of products it produces before getting failed or before its life is over. So, this may be like 50 units are produced by a particular product. So, one which is producing 60 will be offering better life under the identical conditions as compared to the one which is producing just 50 units. So, there can be number of ways to express the time period for which a particular product performs. So, similarly like the life of the pressure cookers is also expressed commonly like the number of years for which the warranty is given by the companies. So, there are different ways to express the life aspect related with the reliability, and based on the reliability only the warranty kind of things are specified. And as far as the specified conditions under which the reliability is being expressed, it mentions the kind of conditions in which the product will be working. It is indoor, outdoor, or the storage conditions and the transport conditions under which it will be used. So, in order to understand the reliability, different dimensions related with the reliability, we will consider one case wherein say a company is manufacturing a product and it evaluates 100 units over a period of 4 months, and the data regarding that is say generated. So, there are 100 units which are to be tested over a period of the time of 4 months during their function. So, here if we see the month wise, here 0 time, the first column is the time, the initial stage, then we will have the first month, then second month, third month, and say 4th month, and the number of units in the beginning are, so units, number of units which need to be tested in the beginning, these are say 100, and the number of units failing. So, the failure of the units, so here in the beginning there is no failure, and here we have say cumulative failure, and then we can say working or surviving units, number of units working or surviving. So, this kind of the data now can be used to assess the various parameters related with, say, the 100 units tested after a particular period of time, say that is 1 unit, say it may be 1 week or 1 month or 1 year, like that. So, if we are finding that 20 number of units that failed are, like, say 20 failed. So, this data we can also mention here. Failed is here, the number of failed is 0 in the beginning. Number of the cumulative failures will also be 20, and the number of units working is here, say like 80. So, at the end of the one unit period of time, 1 unit period of time, the number of units failed is this much, number of units cumulative failed are this much, and the number of units working is this much. At the end of the 2 unit of the period of time, or at the end of the 2 months, say, so our number of units failed is 15. So, the cumulative failure is 35, and the number of units left is 65. Say at the end of 3, again 10 failed. So, the cumulative failure is 45, and the number of units working is 55, and then at the end of the 4th period of time, say we again 5 units failed, and means during this particular period of time, after the at the end of 3 and at the end of 4, the number of failure is units is 5. So, total cumulative failure is 50, and the left out units is also 50. So, this is the kind of data which is if has been generated over a certain period of time, when we are trying to assess, like if there are 100 units in the beginning. So, as a function of time, how many units are getting failed. So, to assess the failure behavior, now we need to find out the various how to calculate the various parameters related with this. Say the first one is the failure density. So, the failure density which we can say FD is calculated using the number of units failed for a specific time period divided by the total number of items in the beginning. So, say if we consider the first period of the time, that is after the first unit after the first months. So, number of units failed is 20, and the number of units in the beginning were 100. So, the failure density will be 0.2. So, if we mention here like FD, then it will be 0.2 at the end of the first month. Similarly, if we calculate the failure density for some other period of time, like say for third period of time. So, the number of units getting failed at the end of the 2 and at the end of the 3, number of units getting failed are 10. So, 10 divided by 100. So, the failure density will be 0.1. So, this is how we can calculate the failure density. There is another parameter which is commonly used is the failure rate. So, failure rate is calculated using the there are two ways basically to calculate the failure rate, and that is like one is the average number of units between the 2 time periods. Say at the end of the at the end of the first month we are having the number of the working units are at the end of the first month we have the number of working units 80, and at the end of the second month we have the number of working units 65. So, what we have to do, average number of units at the end of the 1 month and at the end of the second month is obtained. So, 80 plus 65 divided by 2, this will be the average number of the units which for which the average failure rate will be identified, and at the same time we have to see for this particular period how many units are getting filled. So, the number of units failed in this time period, that is the second time period, divided by average number of units which we have calculated, number of units at the end of the preceding period and number of units at the end of this specific period. So, that will be like say here it will be 72.5. So, the average the failure rate here for this can be obtained through the number of units failed during this specified period is 15. So, 15 divided by 72.5. So, this is one way to calculate the failure rate, where average number of units working units in that particular time period are used to calculate the failure rate. So, now we will look into how to calculate the reliability to perform a given function of, at a specific period of the time. So, to calculate the reliability, basically we have to consider the number of working units at a specified period at the end of a specified period of time, and the total number of units which were there. So, say here in this case the reliability at the end of the first period is how much? Reliability the number of working units at the end of first period is 80 and the number of total units which were there is 100. So, the reliability is 0.8. So, at the end of the fourth reliability to perform at the end of the fourth time period, the number of working units is 50 and the number of units which were there in the beginning was 100. So, it will be like 0.5. So, this is about the reliability, about the number of the number of units that will be working at the end of particular period. So, what is the reliability that a particular product will be performing up to a particular period of time? Say in this case it will be, so if we just calculate the reliability here. So, at the end of the first period 80 divided by 100, at the end of the second period reliability will be like 0.65 divided by 100, at the end of the third period it will be 55 divided by 100, and at the end of the fourth period it will be like 50 divided by 100. So, what we can see here, reliability is getting decreased as a function of time with the increase of the time. So, here like say 0.55 and then 0.5. So, gradually the reliability of the product to perform will keep on decreasing. So, the probability of the failure or the failure probability also can be obtained, or unreliability can be calculated in different way, or the reliability for or probability for the failure is obtained from the failure probability is obtained from the 1 minus the reliability. So, if that is to be determined, so the failure probability of the failure at the end of the first period will be like say 1 minus 0.8, that will be equal to 0.2, and at the end of the second period it will be like 1 minus 0.65. So, the reliability the probability of failure will be 0.35, and likewise we will see that the probability of failure will keep on increasing with the increase of time. Here it was 0.2, then it was 0.35, then 0.45 and then 0.5. So, the probability of failure will keep on increasing and the reliability will keep on decreasing as a function of time. We know that most of the components are not made of the single units. Many times we need to bring the number of components together so that any useful function can be achieved through the products and the processes, and therefore, instead of calculating the reliability of individual products, reliability of the systems is also required to be obtained. So, the system reliability is different. So, next one is basically the system reliability. We know that the system reliability means we are using the number of components like the component 1, component 2, component 3. So, the components can be arranged in broadly two ways, or there can be combination of them, like the components arranged in the sequence like in series like this, or the components are arranged in parallel like this. And so, this is the kind of system here. If you see broadly the component 1, component 2, component 3, component 4. So, 2 and 3 are in parallel and 1, 2, 3 and 4 are in series. Similarly, here the A, B, C, all these components are connected in series. So, when we are having the number of components in a system and the reliability of the each component is different, then how to obtain the reliability of a system as a whole. Say R1, R2, R3 is the reliability for this ABC components, and like say what we can say like RA, RB, RC and RD is the reliability of these 4 components which are connected in a series. So, these are the two broadly two ways by which the systems are clubbed together to make them usable for the different functions, and depending upon the way by which the different components have been arranged, the reliability will vary. So, when the components are connected in series, the reliability of the system as a whole R is obtained from the reliability from the product of the reliability of each individual component, like R1, R2, R3 for the components when the components are connected in series. Suppose the reliability of the product A is 80% at the end of a specified period, reliability of the product 2 is 0.5 and reliability of the product 3 is 0.4 at the end of a specified period of time. So, in order to calculate the reliability of the system as a whole after a certain period of time, what we need to do? 0.8 multiplied by 0.5 multiplied by 0.4. So, this is what will be giving us 0.4 multiplied by 0.4. The system reliability will be 0.16. This is how do we calculate the reliability of the system when they are connected in series. So, this is what we can see here also when the system is connected in series, this is how the reliability can be obtained. So, here if we see if with this kind of reliabilities, if in a system we have just 2 components, then the reliability will be here what we can see reliability in that case will be 0.4. So, in case of the series, when the number of components are connected in series, as the number of components increases, there will be continuous there will be decrease in the reliability. So, what is desired? It is always desired that a system is made of as few number of components as possible, so that it can have the more reliability. So, this is one kind of a system where the different components are connected in series. Then we will take up the another system where like say the different components 1, 2 and 3. So, in this case the components the series is like this, where all of them are connected in parallel, and this is how the system is made. So, in this case also the reliability of the each component will be different, say it is R1, R2 and R3. So, in order to calculate the reliability of the system as a whole, R will be obtained through this simple equation what we can see here. When the system is connected in parallel, then the reliability is obtained through the reliability of the system in parallel is obtained through the 1 minus R1 into 1 minus R2 into 1 minus R3. So, this is how the reliability of a system when they are connected in parallel is obtained. So, here the similarly the values can be put in, like if the reliability of the one component is 0.8, second component is 0.6 and third component 0.5 and third component is say 0.4. So, in order to calculate the reliability of such kind of system when they are in parallel, so we will be doing them 1 minus 0.8 into 1 minus 0.6 sorry 0.5 and into 1 minus 0.4. So, if we see 1 minus 0.2 into 0.5 into 0.4. So, this will be giving us 1 minus it will be 0.2, 0.4, 0.04. So, the reliability of the system will be high, especially in this case 0.96, as compared to the case when the similar kind of reliability, but the components were connected in series, the reliability was very less. So, what we can see here, when the components are connected in the series, for the similar kind of the reliabilities of the individual components, we get this much higher reliability of the system. So, this kind of the arrangement of the systems for high reliability is used especially for those systems which are very critical for the performance and where there is a huge risk of the life and property. So, especially the components like the spacecrafts and the aircrafts, where the two engines are normally used for the passenger aircraft, so that even if one goes out of order, the second one can be brought in and can work in. So, in total the system reliability will be high, and if one fails in, another comes into the action, so that any kind of the mishap can be avoided. For those systems which are like the clubbed systems, then in that case for the club systems, if we see those which are arranged in parallel, their reliability is obtained separately, like for RB and RC, because these two are arranged in separate and separate way, and the remaining 1 and 4 are connected in series with this combined arrangement. So, in order to obtain the reliability in this case, the RA multiplied by, now reliability for this one is to be obtained separately, multiplied by RD. So, this is how the reliability for the system, clubbed systems where both series and parallel kind of arrangement has been used. So, in this particular case, what we have to do to obtain the reliability, what again we have to use the same equation, 1 minus RB into 1 minus RC. RB and RC are the reliability of the components which are connected in parallel. So, their reliability of this combined system will be calculated separately. So, if say R star is the reliability of this parallel system, for which reliability is can be obtained using simple equation, as I have just mentioned, 1 minus RB into 1 minus RC. This is how we can determine for the combined system. So, we can simply replace this entire value with the RA into R star into the RD. R star represents the reliability of the system which is arranged in parallel. So, this is how the reliability for the systems in series and the reliability of the systems in parallel or the combined systems where both series and parallel kind of arrangement exists, the reliability of the system as a whole can be obtained. Now, we need to see it is always desired that a product performs the intended function for a longer period of time without much tendency for the failure, and for that purpose we need to see the certain aspects that will be affecting the reliability of the product, and for that purpose there are three important factors related with the especially mechanical products. The reliability of the product to a great extent is influenced by the design, then the production, and then the transportation or the way by which it is installed and allowed to work in a particular kind of conditions. So, as far as the design related aspects, this is very important, and because the kind of the factor of safety which has been used, the kind of the tolerances which have been identified, the kind of material which is being used, the kind of the arrangement of the different product is there, whether they are arranged in series or parallel. So, all those things will be affecting the reliability. We will be going through these factors related with the design one by one. Here we can see simpler is the product, greater will be the reliability. More the number of units related with the product, lesser will be the reliability. So, efforts are always made to design the products that they are simple in design, so that they are easy to manufacture. Similarly, the fewer number of the components, it is always desired what we have seen, especially in case of series, when as the number of components increases, the reliability of the system comes down. Another way of increasing the reliability, to have the high reliability, we can have the parallel arrangement. But in parallel arrangement, if there are 2 or 3 number of units connected in parallel, so one is expected to perform, others will be redundant. So, that will simply increase the cost, but at the same time it will increase the reliability. So, those systems which are critical from the life and property point of view, this kind of parallel kind of the arrangement is used with regard to the kind of systems which are there. Then over design efforts are made that slightly extra the dimensions or slightly better material is preferred for the design purpose, so that it performs more effectively under the given set of the service conditions. Use of the larger factor of safety means this is also another way of going for over design, where the dimensions over higher factor of safeties will simply leading to the greater dimensions, improved the design of the product, so increased possibility for proper working. And it should recommend also that the proper maintenance is carried out, and the kind of things which need to be done during the maintenance are specified properly, so that the chances for the failure during the service are reduced. In production, especially emphasis is given on those components which are less reliable. Like in a system, we have number of products and units, all may not have the equal reliability. So, those which are less reliable, they must be given enough attention at the time of manufacturing, so that they can be made more reliable. And for this purpose, process which is being used for their fabrication, for their manufacturing, is controlled in much better way. So, we get what is better in terms of the quality, in terms of the characteristics which are required for proper performance. Close tolerance is also in the same line. If the product is being made with a much closer tolerance, then it will have lesser variability and increased chances for giving the desired performance. And sensitization of the people and the personnel or the staff is also done, so that they take care of each and everything meticulously in order to make the products and processes which will be performing the desired function. Similarly, the transportation is another important aspect, like how the components are packaged and shipped, so that in course of transportation they do not get damaged and their capability to perform is not adversely affected. Now, I will summarize this presentation. In this presentation, I have talked about the basics of the reliability and what are the factors which affect the reliability and what should be done in order to have the better reliability of product. Thank you. for your attention.